a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. This lesson about the multiplication and division of mixed numbers is almost obvious if you've done the preceding lessons. We know how to multiply and divide fractions, so how do we multiply and divide mixed numbers? Why, change the mixed numbers to fractions, of course. So changing 3 2/5 to a fraction, that's 15 plus 2 is 17 over 5. This one's 3 plus 1 is 4 over 3. Very obvious, isn't it? And now, because I'm multiplying fractions, I look for cancellations. There aren't any. So multiply the tops and I get 68. And multiply the bottoms, I get 15. And that's my answer, as a fraction reduced, because I couldn't cancel. Now, quite frequently, just for communications alone, the improper fraction will be changed to a mixed number form. But please note, there is nothing wrong with this, and there are many problems where you will be glad to settle for this and you will avoid this. This is primarily used for communications with people in the public. Now, same thing here. To divide mixed numbers, change each of them to improper fractions. And if we do, we get 9/2 divided by 5/3. Now, avoid the temptation to want to cancel here, because we can only cancel across multiplication. However, division is the multiplication by the reciprocal of the divisor. And of course, the dividend, the first number, stays the same. But now in this multiplication form, I'm allowed to cancel, but in this case, there is no possible cancellation. So multiplying across the tops, across the bottoms, it is reduced because I didn't cancel. And if it's the desire of whoever you're working this for to change the number to a mixed number, then we do it by performing this division. So you see, in multiplying and dividing mixed numbers, there's nothing new. It's just a matter of grouping what we already know. So let's state this formally for our notes. To multiply or divide whole numbers and or mixed numbers, simply rewrite them as improper fractions, then multiply or divide following the methods of fractions, and change to a mixed number if that's your desire. Again, to multiply mixed numbers, change each to an improper fraction. So this is 20 plus 2 is 22/5, and this one is 2 times 2 is 4 plus 1 is 5/2. Now, since I'm multiplying fractions, I have permission to cancel if possible, and there are two possibilities here. 5 into each of these once, 2 into these two, into here 11, into here once. And if I multiply the tops, I get 11, and the bottoms I get 1, which I don't need. So my answer is cleanly 11. Now, just a note, always when you have finished, mentally estimate the magnitude of the answer to see if the worked answer seems to be reasonable. That will not only let you quickly to catch gross errors, but it will help you to greatly increase your own number sense. And that's something that's very necessary. So back to our problem. If the fractions weren't there, that would be 4 times 2, which is 8. So our answer has to be greater than 8. That is. If we were to go one higher in each of these, this would be 5 times 3, which is 15. So our answer must be less than 15, which that is. So at least this isn't out of the ballpark. And that's what we call a reasonable answer, by just checking roughly where the answer should be magnitude-wise. That is, overall size without regard to the exactness. Now another division. First, change each of your mixed numbers to fraction form. So this is 24 plus 5 is 29 over 6. But this whole number as a fraction is simply the whole number over 1. Then we recall that division is nothing more than multiplication of the reciprocal of the divisor. The dividend, the first number, stays the same. Now that we're multiplying, check for cancellation. There isn't any. So then follow through on your multiplications. Then if your answer is an improper fraction and you desire to have the answer as a mixed number, then simply perform that division, which would give me 2 and 5 twelfths. And in time, you must be able to do this division mentally. If you cannot at this stage, that's okay, and you're doing it on scratch paper. Now let's check the reasonableness of this answer. This is about 5. Greater than 4, less than 5. And 2 into 4 is 2, so our answer must be greater than 2, but just somewhat greater than 2. And this one is. So at least the answer is not out of the ballpark. That's what we mean by a magnitude check of the answer. Now let's use this knowledge in our continuing quest to get ready for algebra or working formulas in other courses. If we were reading this, this says 2/5 times some number is 3/25. So the question is, how do we solve a simple equation involving fractions? And the answer is exactly the same as we would have done one without fractions. Recall, if you're trying to undo multiplication, the trick for undoing multiplication is division, and of course both sides. So this division undoes this multiplication, and that leaves you with my sum number is, in this case, 8 divided by 2. So it's exactly the same thing here. We have a number times 3/25. To undo, that rule states that if I divide this by 2/5, this will disappear, leaving me just the m, but then I must divide the number over here, which is the same thing as all of this, by the same amount. And now this is m is 3/25 divided by 2/5. So division is multiplication by the reciprocal of the divisor. The dividend stays the same. Check for cancellation. There's one there. Follow through on the multiplications. 3 times 1 is 3. 5 times 2 is 10. And I'm done. So my number, which we call m, is 3/10. Now, let's check. We're claiming that m was 3/10. Well, the sentence is also claiming that if I take 2/5 times m, which we now think is 3/10, the product should be 3/25. Let's see if that's the case. Since I'm multiplying here, there's a cancellation that I can do. Following through on the multiplication, that gives me 3 on top, 25 on the bottom. 3/25, it checks. So just remember, in simple equations of this type, that division still undoes multiplication, whether you have a fraction or a whole number. It's that simple. Now let's look at the same problem a different way, because many teachers prefer this technique because it's much cleaner. It's true that multiplication is undone by division, but remember, division is nothing more than multiplications of the reciprocal. So you can think I can undo multiplying by a fraction by counter multiplying by the reciprocal. And of course, the both sides of the equation. And we know that a number times its reciprocal is 1 times m, which is what I'm after. Then again, follow through here, and you still get 3/10. See, by approaching it with the multiplication of reciprocals, both sides, it's a much cleaner operation. So whichever of the two approaches you prefer or is preferred by your instructor, use it. They're both logically correct and the same. Let's try one more. Now, very frequently, instead of writing a problem like this as 8/9 times b that way, it's much cleaner to have the variable on top, which is where it really is. See, let's look at this. 8/9 times a number, but I can always write a number as that number over 1, and it doesn't change. And if I'm multiplying fractions, I multiply the tops. So 8 times some number called b, well, that's what we have here. And 9 times 1, that's what we have here. So you can look upon this as 8/9 times b. But now, using the fact we just gave you, if I were to multiply this by 9/8, that's undoing multiplying by 8/9. So the net effect is that I have only b, which is what I'm after. But if I'm multiplying this side by 9/8, the reciprocal of that, I must multiply this side by the same amount. Check for cancellation and then multiply. 81 on top, 40 on the bottom. Then if you need to or wish to, change to a mixed number, and we're done. But now see, if I wanted to check, it's easier to check with the improper fraction form, because this says 8/9 times b, which we're now claiming is 81/40, we hope will be 9/5. Well, let's check and see. I can cancel here. 9 goes into 9 once, into 81/9. 8 goes into 8 once, into 45, and that leaves me 9/5, and it checks. So to undo multiplying, you multiply again by the reciprocal, but both sides if you're solving an equation. Now let's summarize this lesson by walking through one example of each kind of problem which relates to this lesson. And perhaps that way we can not only tie this lesson together with previous lessons, but with vocabulary as well. First, we began a lesson or so ago the simple multiplication of two fractions. And we simply defined the multiplication of fractions as the dual question really of asking, if my answer is a fraction, what's going to be the top or numerator of the fraction, and what's going to be the bottom or the denominator of my answer fraction. And we had defined this process to be simply this. To get the new top, you in effect multiply the old tops. And to get the new denominator or bottom, you multiply the old denominators, then reduce if possible. Remarkably simple, isn't it? To get the top, multiply the old tops. To get the bottom, multiply the old bottoms. But while we're at it, let's recall some terminology. In general, do you know what the generic word is in mathematics for pieces being multiplied? I hope you recall the word factors. So 2/7 and 5/3 are factors of that expression. Now do you recall the generic word for the results of having multiplied? The product. A lot of people, when you ask them what the word product means, they'll say it means to multiply. No, it means the results of having multiplied. And the word factor are pieces in the process of being multiplied. It's very important that you pick up the vocabulary as we move along, because eventually you'll get the bulk of your learning, if you will, from textbooks. And these words are used very, very precisely. And if you're not tuned in precisely to what they mean, then that means even though you are reading with good intentions, the words aren't sinking in with precisely what is intended. Then the lesson moved on to the same kind of a situation, but where the numerators and denominators were becoming somewhat messier. And had you multiplied the old tops to get the new top, and the old bottoms to get the new bottom, you would have got a rather messy fraction. And a fraction that's quite reducible, and the reducing itself can take a little bit of time and sometimes get a little bit of trying to you. However, with multiplication, and only with multiplication, we noted a special situation. That is, I may divide any amount I want to any top multiplier, providing I divide the same amount into some bottom multiplier. So you might note here that I can divide each of these by 3. 3 goes into 6 twice. 3 goes into 45 15 times. However, because I divided across here, and since I cross out as I divide, we begin to call this law the cancellation law. Because actually I am dividing. The cancellation is something I do after I have done the division, so never forget that really I am in a process of division. Some students will mistakenly call this the cross cancellation law, because very frequently it's the division across that multiplication sign that grabs our attention first. But remember, the rule said I may divide any top number by any amount I want, providing I can find some bottom multiplier to divide by the same amount. And so in this case, I see I can divide each of these right above each other by 5. And of course here all I'm doing is reducing this fraction. And always remember, you can reduce any fraction anywhere we want in any problem, multiplication or otherwise. However, I can divide across only a multiplication. Bear that strongly in mind, only across multiplication. Then when I see there is no more division I can do, pairwise, top and bottom, anywhere, we divide the old numerators to get the answer numerator, or the product numerator, and the factor denominators to get the product denominator. And at this point, if we've done all the possible up-down divisions here, our answer is in reduced form, which means that our 150 315ths, which we got in the first place, is reducible to 10/21. But it's easier to reduce here in pieces than it is here in the totality. So when you're multiplying fractions, make liberal use of the cancellation law, but do remember the cancellation law is a special case of division, and that you can always divide top and bottom of single fractions anywhere, but you can divide across only multiplication situations between fractions. Then from there, in this lesson, we move to the multiplication of mixed numbers. But all we need to do there is recall that a mixed number can always be written in a pure fraction, which we call improper fraction form, by multiplying the denominator times whole number added to numerator. So 5 times 2 is 10, added to 1 is 11, and of course the denominator stays as it always was, times, changing this mixed number to a pure fraction, denominator times whole number plus numerator. 3 times 1 is 3, plus 2 is 5 over 3. Now I simply have fraction times fraction. So before we multiply, we look up and down, see if I can find any cancellation. And of course there is. 5 goes into 5 once. 5 goes into 5 once. And again, we remind you, you are not simply canceling or crossing things out. You are dividing. And 5 goes into 5 once. 5 goes into 5 once. There is no more division I can do top or bottom. So I multiply the numerators of the factors to get the numerator of the product. Multiply the denominators of the factors to get the denominator of the product. And since this is an improper fraction, it's traditional to write it in mixed number form. So 3 goes into 11. Remember, this means divided by, so 11 divided by 3 is 3, and the remainder is 2 over the divisor 3. And again, we will assume from here on out that simple fractions like this you can change to the mixed number counterpart or back again very quickly, comfortably, and mentally. But the point of this review problem is this. If you're multiplying mixed numbers, we recall that mixed numbers can be changed to pure fractions, called improper fractions in this case. Then you simply multiply them after first checking to see if you can use the cancellation law. Then after doing the multiplication, if desired, change it to a mixed number form. Then we moved on to division, cautioning you that you do not want to attempt to cancel across division, only across multiplication. So we cannot divide both of these by 5 because this is not multiplication. But we recall that division is nothing more than multiplication by the reciprocal of the divisor, which is that number which follows the division. And of course, this number, the first one, stays the same. So division is multiplication by the reciprocal of the divisor. Now that this is multiplication, then we may seek out cancellations. And in this case, 3 goes into 6 twice, 3 goes into 15, 3. There is no more, top for bottom. So multiplying the numerators of the factors to get the numerator of the product, then multiplying the denominators of the factors to get the denominator of the product. We're done. Then, in this lesson, we simply move to the next logical step of dividing mixed numbers, recalling first that each mixed number can be changed to a fraction form. So this would be 6 plus 2 is 8 over 3. And this mixed number can be changed to 5 plus 2 is 7 over 5. being cautious not to cancel across division even if it seemed possible, but then recalling that division means multiplying by the reciprocal of the divisor, leaving this called the dividend alone, and then simply do the multiplication between fractions. First checking to see if I can divide or cancel anywhere. I cannot. Then divide the old tops to get the new top, and the old bottoms to get the new bottom, or using more precise terminology, multiplying the numerators of the factors to get the numerator of the product, then multiplying the denominators of the factors to get the denominator of the product, then changing this to a mixed number if that's what's desired by simply reading this sign as divided by. So 40 divided by 21 will go once with a remainder of 19 over the divisor, and we're done. Again, be clear on terminology. The number we're dividing by in math is called the divisor. The number we're dividing into, however you write division, the number you're dividing into we call the dividend. And the results of having divided we call the quotient. Much of the difficulty that students have when they get into more advanced math is not so much that they don't know how to do an arithmetic process, but that we're going to use the terminology later in algebra and more advanced math to explain more complicated processes than this. And if one is not precisely clear what each of these words denote, then whatever the instructor is saying or the book is saying, because after all we only have words to communicate, isn't communicating with the student. So you'll find many students who will say they don't understand the instructor or the book. And what it really boils down to is this: the book and the instructor are intensely clear. Is that the student is not clear on the words, which must be learned at this point in order for you to be comfortable with them at a later point. So let's conclude with an emphasis on vocabulary. Dividend is the number you're dividing into. Divisor is the number you're dividing by. Quotient is a result of having divided. And of course, if you're multiplying, the pieces you're multiplying are called factors, and the results of having multiplied we call the product. Goodbye. This is your host, Bob Fennell. Until your next lesson.